Hello viewers, welcome back to video tutorial on AI AgentGrid. In the previous video, we have shown what AgentGrid is, and we just gave you a couple of details related to Gen 1, Gen 2 and Gen 3, which is AgentGrid, and architecture diagram, and also we try to explain one pattern, agentic pattern on a sequential pattern. So in this video, we'll be dealing with the second pattern known as conditional sequencing agentic pattern. So let's get started with the conditional sequence pattern. So most of the details which is at the top, it's same from the first video as well. So you don't want to know more about agentic patterns, you can click on the links here, and to know more about AgentGrid and documentations, you have links here. These things already I have explained in the video, the first video, like Agent LLM SDK and Agents SDK. So the sample code snippet is also present here, so I'll not again discuss that. So right now, the use case that I'm taking is a coding task with a feature or a bug triage using a conditional sequence flow. So here you will get an input. The input is maybe a partial code or a feature request code, and we need to maybe normalize the text. Maybe like since it's a code, dev might give some short words for certain things like infra kind of thing, or dev bug. So some certain words that dev generally uses. So that needs to be normalized, and also condition needs to be checked whether it has to be moved to a coding branch or a feature request branch. So that check will happen in the text normalizer agent, and then based on the condition meeting, so it will just pass on that to two different sub agents. So here I'll not be using an LLM to identify whether it's a bug feature or a coding feature, bug fixer or a feature addition. I'll use a simple check like based on certain strings or words in the code in the input, and then a final synthesizer or a aggregator is required. So that agent, like if you see here, right, so that this agent either takes this or takes this, but not both at the same time. So, and it aggregates it and it summarizes it, what it has done, why it is required, things like that. It will try to summarize with the help of LLMs, and then final output will be given. So basically we require 4 agents here. One is a text normalizer, bug fixer, feature addition agent, and a final aggregator or a summarizer agent. So let's go one by one. The first code text normalizer, a piece of code with a bug or a feature request, a raw text will come here. Normalize the text by fixing obvious casings or spacings, or correct glaring typos, or expand common infra abbreviations. Decide whether the bug or feature request from the user input with semantic check, and return a normalized text with a bug fixer agent or a feature request agent. So let us go to the code. So here the coding, the base code remains same, almost same. Only thing is what you would see is a different signatures, maybe according to the use case. So here there is a normalizer signature, and here is a doc string. So if you read the doc string, your agent 1 expert draft normalizer user short draft without adding or removing facts. And yeah, this is very important. I'm not adding or removing any facts from the user input. Fix obvious casing, spacing, correct glaring typos, expand common infra abbreviations, keep original meaning uncertainly. Do not invent steps, logs, metrics. Critical, you must preserve any note or instruction section exactly as they are. They are vital for downstream routing. So this is a doc string, and also output fields, normalized text, number of counts, and word counts. So these are just extra informations. So this is what the doc string is, and this will be the system message for this particular when the DSPy uses this for LLM, right? So this doc string or a system message coming out of our JSON files, which is the agent2.json file, will be used. So right now, whatever the doc string here, it will be same. It will be available in our agent2.json file as well. Let me just show you the agent registration file. So normalize the text. So yeah, let me go to the next section by the time the file loads. So you have to there's an input field known as text, and 3 output fields of normalized text, character count, word count. So these are 3 output files. And next module, normalizer module, which takes the it requires just the predict only. It doesn't require a chain of thought. So we don't want to know what is going on with the while converting our input to our output. We don't want to know it, just want a prediction only. And a signature with instruction is sent. So this is basically we are passing a system prompt which is available in the agent2.json. So now there is the default system message, right? So that will be passed to this particular normalizer module. Then this is just basically input parsing. So whatever you are getting an agent task as an input, I'm just parsing it what I need, and that I'll be returning it. So I don't have to mix it in my main code. And a model context manager, which will basically provide you the context required for DSPy. This facility given by the DSPy library, so you can set a global context, and with the help of utility, right, with function, we can basically with self model context get context. So I can set the context for the whole DSPy module. And the self.module, the module here is basically a normalizer module, which we have here, normalizer module. And the forward function will be called whenever we are doing a dot operation on it. So whenever you do a dot operation, self.module, and if you are passing a text, forward function of the module will be called. And the predict self.predict function is called basically. So here rest remains the same. So you have a normalizer module, DSPy, LM, agent payload processor for passing the input, model context for getting the context for a LM. Agent config YAML as the same as previous. So it has information related to who is the next agent. So let me just show you the content of that. So next, in on preprocess, nothing much, the same as previous. And in on data, so whenever the input is received, a prepare input is called, which will return the required input by downstream. And then we are creating an random session ID, and then we are calling an execute worker with the input text. So that will give us a normalized text or characters and word counts, and that will be put in a JSON file, and we are dumping that JSON file. So here is an agent YAML file. So for coding task, who is the next task? So coding text normalizer, there is a special condition. And for bug fixer agent, who is the next? The final aggregator agent. And feature improvement, also a final aggregator agent. And final aggregator agent, there is nothing. No, there is no next agent. So basically my py files will read that YAML file content, and it will decide who is the next agent wherever condition or a check is required, right? So it will not do that. It will not take that data from the YAML file. It will only decide where to go. So now I have one specialized function here, root function. If I give a normalized text to it, it will try to identify who is it, whether it is an feature or whether it's an a coding. So this root function, let me show you that what that function does. So it is in utils condition. Let me go to utils condition.py. So as I told, we could have used the LLM, but I'm not right now using it because I'm just check with a simple words only. So whether it's a bug or a feature request, semantic little search. File is loaded. Okay, there are a list of strings, whether what it is bug or whether it's a feature. For feature we could have said these words, or for a bug we could have said these words. So I'm just simply doing the counts, and based on the count, whichever is having an highest score, right? So that will become the choice. So this is a simple function. There is nothing much in here. So we could have, as I told, we could have used a LLM as well. So with that, I will check whether any signal is there or not, to say whether it is going to this or that. I have signals or not. So if no signals are there, then I'll identify who is the net, for where I have to route it, whether it's a bug agent or whether it's a router, the feature agent. So with that, I will take a call here, and I'll create the state, what all we need to pass. Basically, input text needs to be passed, normalized text has to be passed, and the routing decisions and routing reasons will be passed here, so that the next agents, if they needed these details, right, so they can use that. So basically I'm passing on all the details needed by the next downstream agents, and I'm JSON dumping it so that I can pass on this JSON string to the next agent. And I'm creating a structure known as task data. This task data is will be passed by the passed to the next agent. So based on the communication type, whether you want a P2P or a delegate or a direct method, so we'll be using the self.context here, and we'll be passing on in the context there will be P2P managers, delegators, and submit. So this will be provided by AIOS and the AgentGrid, and we'll be passing on the input to it with the help of our task data and the subject ID, next subject ID. And so if any if it will return the operation X, so it is just a placeholder for saying that okay, the operation is passed to the next agent and I don't have anything to return, so I'm simply passing a operation pointer. That's it. So this is the first agent. So let's go back to the second agent code. So let me open all the three agent codes. Okay, so this is a bug fixer agent. Again, it has the same structure. There is nothing changes. So it has a doc string. The doc string is for our reading, but we'll be passing the actual system message from the JSON file only. So improved markdown must be head-to-heading. So I'm just giving instructions what all I needed, and so basically normalized text will be passed, and these are the output fields expected from it. And a module is created. It is same, there is no changes at all, so you can go ahead and read this yourself. So if an input comes here, then it will be broken down. It will identify normalized text, things like that, and the normalized text will pass to the LLM. Since it's a bug, it has to improve the markdown code as well. It has to give the corrected code, it has to give the improved markdown. So those are the output expected from the LLM. So the improved markdown, corrected code, key section present, actionable checks, etc. Those are the things that we are asking from the LLM to provide. And here we are using a chain of thoughts, not a predict function, because we want to say its reason why it has selected, why it has given those details. And then again we are performing an output JSON structure, so that will be passed on to the final aggregator. So we are sending the improved markdown, corrected code, key section present, and actionable checks. All these details will be sent, and along with the previous states, improved markdown. So all those things will be updated here in the state, because the state only will be passed, not this. The content of output JSON will be added in the state, and that will be passed to the next agent. So next agent, because it knows that what is the next agent, it is hard coded in our YAML file as a configuration. So from the configuration, it will identify the next agent. I don't have to again give that words. Who is the next agent, like agent final aggregator or something like that. So it will take from the agent file, YAML file, and then it will be passed on to the next agent using the communication protocol. So this is for the bug, and for the feature also it will remain almost same. Only the DSPy signature will change, and what it expected: improved markdown, improved code. It is not a fixed code, a bug fixed code. It's an improved code. It's a feature addition, right? So improved code is expected, and key section present and action checks, and rest remains almost same. There is no changes at all. And then at the aggregator, so we are giving again aggregator signature is present here, try summer, and pass the upstream input which contains improved markdowns, key section present, actionable checks. Extract the corresponding code snippet from the input, either corrected code if it is a bug, or improved code if it is a feature request. title text from the first heading and clear first sentences, one line summary, body markdown, quality flags. So we are just asking it to provide a report. We are providing a input report JSON to be provided, and it has to provide us like type, title, online summary, body markdown, quality flags, final code that we need to pass on to users. So all these details we are expecting from the DSPy. So rest remains the same. Once we get the output, we are returning that output to the user. So here there is no OPEX, we are just passing the output JSON dumped content. So this will be passed to the user at the end. So let me try executing the code. So the execution pipeline remains the same. Build all the Dockers, do the registration, deploy the agents, and send the input to the first agent, and then once output is received, you can turn off remove the agent. So I'm going to run the all.bash, so which has all these 4 steps together. So let me just run it. It is trying to delete if any agents are present. If not, it will now build the Docker, push it to the registry, and then register the unregister the agents, and then register those agents again, because if you have modified any JSON file content, it will do a re-registration and then deploy the agent. Sleeping is of 30 seconds is required because the Dockers will not be immediately removed. It might take some time. It's a Kubernetes cluster, so we are just keeping a 30-second sleep here. Now the building process is going on. Once building is done, it is pushing the Docker to the Docker registry. Yes, it has built all the 4 Dockers. Then it does the unregistration, and it does the registration, and at the end a deployment of 4 agents. So deployment is also done. So now you can check the pod details. It's 4 executors are there, and 4 instances are there. I have explained what executors are, which is having 3x3 containers, and this is the instance code. So we can check one by one. So first let me take the normalizer agent. Let me copy the first agent, pasting it here, the first agent. Then let me take the bug fixer agent. It's the bug fixer agent. It's the first agent. Now code text normalizer agent. Then feature improvement agent. And then final aggregator agent. Okay, so let me run the input request. In the let me show you the inference request file. Agent registration, conditional sequence, inference request.sh. So in this sh file, basically we'll be having a checking of both bug as well as a feature request. So I'll just show you the inputs that I'm providing in the inference request.sh file. Yes, so the first one is a bug case where I'm providing a piece of code, Python code, and I'm saying there is a bug in it. Identify and handle the bug in this piece of code. So it has to identify the bug and it has to fix that bug. And to run it, I have just created a bash function, run triage, and a bug branch and the bug text. And feature case, I'm requesting a add gzip compression support for to export CSV via compressed true flag. So I'm asking basically to add one more flag here, and it has to zip compression while writing the CSV file. So that's what I'm asking. So let me just try to comment this out so that we don't call the feature request now. So we'll test only for the bug branch. So let me run it. Okay, let me do the inference request. Okay, so this is the input. If you can see that, so a feature request, a code text normalization is done. So basically it is asking for a input text and a normalized text as output field. These are the signatures, like the DSPy is curating this for us, not we are not curating it. It is the system message that we have passed. And once code text normalization is done, since it's a bug, it goes to bug. As you can see here, there is no logs in the feature request. The first second is a bug fixing, so bug fixing is done, and at the end it goes to the final summary report generation or final aggregation. So let us see the output. The output is yes, bug in export CSV. The export CSV function fails to handle byte string in the bad list, leading to an error. So it will try to update the final corrected code. So similarly, let us handle the feature branch now. I just enabled the feature request, and let me comment the bug section. Okay, so it is saved, and let me rerun it again. So add a gzip compression support to export CSV via compress flag. So let us see whether yes, the task has come to the feature request and to the final aggregator. So it's going on, waiting for LLM results. Right now I'm using a very small model, Quen 3 1.7b, using a VLLM, and it is deployed in our AI OS. So yes, this is the output. Add gzip compression support to export CSV function. So, and it is giving a lot of details here, and a final corrected code. So it is adding a compress by default of false, and if it is true, it goes for a compression as well. So this is the a triage for a bug or feature request. And why conditional sequencing? You have a sequence of agents doing their task, but there is a condition, but that condition right now is not activated with LLM, but we are doing simple check, semantic based check, or a score based check to take that condition into effect, and the final aggregator will be there. So there is no need of a mux right now, because the final aggregator either gets a bug or a feature request. When both are there, what needs to be done? Those are our next patterns, subsequent patterns, we'll be discussing it. And to remove the running agent, so you have to just run the remove agent.sh. Yes, it has tried to remove it. Let us see the export. Yeah, all the executors and instance pods are getting terminated. That's it for this video. I hope you liked the conditional sequence pattern explanation given in AgentGrid. Thanks for watching, and keep supporting us. Thank you.